So this is a cantilever beam, and it has 500 mm length. This total length is 500 mm, and the cross section is box section. This side it is 20 mm, and height is 30 mm. So this is the beam, and this is the beam section, and we will do the normal mode analysis of this beam. And this side it is fixed. This is a fixed side, and this side it is free. Normal mode analysis we will do for a cantilever beam. So we will take a node in the 0 0 0 coordinate, 0 coordinate, 0 0 0, first node we have taken, but it is not visible. Just you make fit window. Okay, then second node will take in the x-axis direction only, in 500 mm distance. So in x-axis we put 500. So create one more node. It is also not visible. Just put fit window. It has both is showing, node 1, node 2. Then we will create a line. So to create line, we have selected this one, that line created using nodes. So we have selected first node, second node, then create line. So line has been created. Then next we'll mesh it. So before meshing, we'll make the property, material property, beam property, all those things. Create, go to model, right click here. So it will go to create, then material property. Okay, so we'll make material property as steel. So we'll then that property we have to assign here e value, g not required, new value, and row value. Any two if you give, third one will be automatic and taken care. Okay, so we have created this material property. Then we have to make a beam. This is the beam you have to make. So that beam cross section you have to make it. Go to mesh, go to element and hyper beam. Go to standard section, hyper beam, thin wall, box section. Create thin wall box section. See, beam has been, that beam section created. We have to specify the dimension that we have taken. 500 mm is the length, and that vertical height is 20 mm. Horizontal it is width is 10 mm only, thickness is 2 mm thickness. Okay, so it has been created. Box section, you can give name. (30 into 20 into 2 mm thickness). Thickness T. So we have made the section. So beam section created. Name also will put. This is box section. In this name and all, try to avoid putting space. Anything you put underscore. So this is box section. We have created component also. Component is a cantilever beam. We will give proper name. Cantilever beam. You have created the cross section, you have created the beam material, then you have to mesh it now. We have to property. One more thing, we have to create the property. So property created. So property is a beam property. P beam. Now we have to define the property. So here by default it creates shell, so we have to change it to beam. Then material we have to define. So material already we have created. We will define the material as steel. Then beam section it is asking, you have to already created, define the beam section. Okay, so all this area moment of inertia it is showing here, area also showing. So beam property has been created. Next, now we will do the meshing. So go to line mesh, select the line. It is 500 mm length. Just assume we wanted to create the element 500 mm length. So if 50 mm length element if we create, then 10 element will be created. So let put 50 here. Okay, then property will define, already we have created, just p beam. So we have defined property also. Element configuration type bar2. Now let's this component, that z axis, put z axis. So in let do the meshing done. See that section how you have taken, whether it has come properly or not. See beam section on. It has come square section, but we wanted to use rectangular section, so you have to check beam section whether it has taken properly or not. See here, okay, it has not taken properly, so it will be 20, 10, and here it is 2 mm. See, now it has come. So like that way you can cross verify also, and we have to cross verify if any mistake happens or not. Here you can see this, it is wire frame it is showing, see solid. Okay, so our sections are all correct. Now we'll switch off this. You can shrink. If you do shrink, then how many element you will be able to see? 1 2 3 4 5 6 7 8 9 10. 10 element, 50 mm length each element, total it is 500 mm the beam length. Now I'll switch off this also off. Okay. The temporary node also not required, just we'll remove that node also. Temp node, clear all, it is gone. It is showing that element as well as line is not required. We switch off the line also. Now we have to set the boundary condition. Constraint. So all degree of freedom we have to arrest. So 1 to 6 all are check. Then you have to select the node selected, create. So boundary condition will be coming in node, in that load collector, and in that load collector it has come in the name of auto. Just will change the name. It is FIX fixed. And one more load collector also will take, because the normal mode card we have to define. So we'll put the name EIGRL. So in this we have to select the card EIGRL. So it has come. So now the starting frequency 0. Just assume some 10 frequency I wanted to see. We put 10. Okay, normalization mass. Now both load cases we have created. Then we have to create load step. In that load step we have to define this. So it is normal mode. So load step created. Just you have to define analysis type, normal mode. SPC we have to do. SPC means single point constant, that is there inside the fixed load collector. And method will select EIGRL. Okay, then we'll go to OptiStack and define the somewhere FEA. I'll create a new folder. I'll save it here. Cantilever beam normal mode .FEA. Okay, this one will be displayed analysis 5000. Okay, now we'll do the analysis. Analysis is running. Okay, analysis is completed. Results. Now result is opening. Result will be opening in Hyperview. So from this analysis you will be able to find the frequency of that beam, and also you will be able to visualize the mode shape. So basically this frequency analysis required to see the behavior of the structure, what is the fast mode or fundamental frequency of the structure when you will excite in so whatever excitation frequency should be much away from the resonance frequency. So whatever is the natural frequency and same frequency, if you excite, then definitely uh, it will resonate and system may fail. Now it has opened, that hyper view has opened. Now we'll see the mode. So go to contour, this eigen mode it will show. See, it is showing that fast frequency. See, it is a 4 hertz, 41 hertz plus 1 is there, 10 to the power 1. So 41 hertz is the fast frequency, and we can see here how it is the mode shape. We'll just increase the scale. In that xy direction it is deflecting. See, xy direction it is deflecting. Fast mode, we can see the second mode, that is 76 gigahertz. It is in xz plane, it is deflecting. Third mode, see, third mode, one node has been created. Fourth mode, fifth mode, sixth mode, seventh mode, eighth mode, ninth mode, 10th mode. So you have seen how to analyze the normal mode analysis for a cantilever beam. So similar way all others, then this is just I have shown the procedure, so you can do for other thing also. And if you face any problem, so please write in comment, and if you like this video, then please subscribe my channel and put a like button. Thank you.